Good evening, everybody. Yes, my name is Stephen D'Souza. Yesterday, I was teaching you about amines. Yesterday, we have already seen the preparation of amines, properties of amines, chemical reactions, and all. Today, we will study about diazonium salts. First of all, we will see what are diazonium salts. Diazonium salts, they have the general formula Rn2 plus X minus, where R is an alkyl group, aryl group, and X can be chlorine, bromine, HSO4 minus, or BF4 minus. Now, the N2 plus group in diazonium salts, it is called as diazonium group. Now, for example, C6H5N2 plus Cl minus is called as benzene diazonium chloride. Similarly, C6H5N2 plus HSO4 minus is called as benzene diazonium hydrogen sulfate. Now, these arene diazonium salts, they are very much stable than alkyl diazonium salts. Now, the stability of arene diazonium salts can be explained on the basis of resonance. Next, we will see how to prepare diazonium salts. Now, benzene diazonium chloride can be prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin. So this nitrous acid actually it is produced in the reaction mixture by the reaction of sodium nitrite with hydrochloric acid. Now this reaction is also known as diazotization. So this is how we prepare diazonium salts. So when aniline is treated with nitrous acid at 273 to 278 Kelvin, so we get diazonium salts. So this reaction is called as diazotization. Now, for example, aniline. So when you treat this with sodium nitrite and hydrochloric acid at around 273 to 278 Kelvin, you get benzene diazonium chloride. Next, we'll study about some of the chemical reactions of benzene diazonium chloride. So first reaction coming in chemical reaction is replacement of the diazo group by halide or cyanide ion. So chlorine, bromine or cyanide ions can be easily introduced into the benzene ring in the presence of Cu1 ion. So this reaction is called as Sandmeyer reaction. This reaction is called as Sandmeyer reaction. So as you can see here, this is benzene diazonium chloride or benzene arene diazonium salt. So when this is treated with cuprous chloride and hydrochloric acid, you get aryl chlorides or chlorobenzene. Similarly, bromine can also be introduced into the benzene ring by using this equation ArN2 plus X minus in the presence of Cu2, Br2 and HBr, giving you ArBr. So this reaction is called as Sandmeier's reaction. Alternatively, chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid in the presence of copper powder. So this is called as Gattermann reaction. This reaction is called as Gattermann reaction. Next, we'll see how to replace this diazo group by iodide ion. So when the diazonium salt solution is treated with potassium iodide, you get iodobenzene. So when benzene diazonium chloride is treated with potassium iodide, you get iodobenzene, or we call it as aryl iodide also. Similarly, we can replace diazo group by fluoride ion. So when arene diazonium chloride is treated with fluoroboric acid, so you get arene diazonium fluoroborate. That upon heating, it gives you aryl fluorides. You get aryl fluorides. ErN2 plus Cl minus fluoroboric acid. You get diazonium fluoroborate. And that upon heating, you get aryl fluorides. Replacement by hydrogen. So mild reducing agents like hypophosphorus acid or ethanol reduces diazonium salts to arenes. So here you can see arene diazonium salt is treated with hypophosphorus acid. In that case, you get arenes. And hypophosphorus acid itself gets oxidized to phosphorus acid. Similarly, when diazonium salts is treated with alcohols, again you get arenes. Next reaction, replacement by hydroxyl group. Now, if the temperature of the diazonium salt solution is allowed to rise up to 283 Kelvin, so they become highly unstable, the salt gets hydrolyzed to phenol. So phenol is obtained. So whenever the temperature of the diazonium salt solution is increased, the salt gets hydrolyzed and phenol is obtained. Next reaction we'll see replacement by NO2 group, nitro group. So whenever diazonium fluoroborate is heated with aqueous sodium nitrite solution in the presence of copper, the diazonium group is replaced by NO2 group. So this is how we can introduce NO2 group into the benzene ring. Benzene diazonium chloride So this when it is treated with fluoroboric acid, you get benzene, diazonium, fluoroborate. This upon treating with sodium nitrite in presence of copper, you get nitrobenzene. So till now we have studied the reactions involving displacement of diazo group. Now we will study the reactions involving retention of diazo group, or we call it as coupling reaction. So in coupling reactions, benzene diazonium chloride is made to react with phenol, in which the phenol molecule at its para position is coupled with the diazonium salt to form para-hydroxyazobenzene. So this type of reaction are called as coupling reaction. Similarly, the reaction of diazonium salt with aniline gives para-aminoazobenzene. So these compounds, they are often colored, and that's why they are used in dyes. Next, we'll study the importance of diazonium salts in synthesis of aromatic compounds. First one, the diazonium salts are very good intermediates for the introduction of fluorine, chlorine, bromine, iodine, cyanide, hydroxyl, nitro groups into the aromatic ring. Aryl fluorides and iodides actually cannot be prepared by direct halogenation, very difficult. The cyano group also cannot be introduced by the nucleophilic substitution of chlorine in chlorobenzene, but cyanobenzene can easily be obtained from diazonium salts. So these are these are some of the importance of diazonium salts in the synthesis of aromatic compounds. Now we'll discuss some of CET questions. The first question is, the basicity of aniline is less than that of cyclohexylamine. This is due to, so there are four options: plus R effect of NH2 group, minus I effect of NH2 group, minus R effect of NH2 group, and D hyperconjugation. So as you know, aniline is NH2 group is directly attached to the benzene ring. Now, in case of aniline, the lone pair of electrons which are present on nitrogen, they are in conjugation with the benzene ring. So that is called as plus R effect of NH2 group. And that's why these lone pair of electrons, they are not available for donation. But in case of cyclohexylamine, there is no resonance possible. As a result, the lone pair of electrons on cyclohexylamine are easily available for donation. This is cyclohexylamine, this is aniline. So the answer is because of this plus R effect of NH2 group, the basicity of aniline is less than that of cyclohexylamine. Second question, which of the following would undergo Hoffman reaction to give primary amine? As you know, what is Hoffman reaction? So in a Hoffman reaction, an amide is treated with bromine and potassium hydroxide. You get an amine, primary amine. So in this case, this is not an amide. This is an amide, but it is a secondary amide. This is an ester. So only the answer is C because this is a primary amide. So in Hoffman bromamide reaction, we take primary amide to convert it into primary amine. So this is the C is the correct answer. Third question. Hoffman's bromamide reaction is used to convert options A acid to alcohol, B alcohol to acid, D amide to amine, and D amine to amide. Now again, this is Hoffman's bromamide reaction. So in Hoffman bromamide reaction, an amide is converted into an amine. So answer D is the correct answer. Fourth question. An alkyl halide reacts with alcoholic ammonia in a sealed tube. The product formed will be. So there are four options. A tertiary amine, B secondary amine, C a primary amine, D a mixture of all the three. So I have told you ammonolysis of alkyl halides. So when ammonia is treated with alkyl halide, you get a primary amine. That primary amine in turn, it reacts again with alkyl halide to give you a secondary amine. And then the secondary amine again reacts with alkyl halide to give you a tertiary amine. And finally, quaternary ammonium salt. So in a reaction of alkyl halide with alcoholic ammonia, you get all the amines, primary amine, secondary amine, tertiary amine, and quaternary ammonium salt. That's why the correct answer is a mixture of all the three. A mixture of all the three. Next question. Amines behave as a protic acid, a neutral compound, Lewis acid, D Lewis base. So as I told you, in case of amines, the nitrogen present in amines contains a lone pair of electrons, unshared pair of electrons, which can be used for donation. So that's why it acts as a Lewis base. So according to Lewis, a base is a substance which can donate a lone pair of electrons. So amines, they behave as Lewis base because of the presence of lone pair of electrons on nitrogen atom, which can be easily donated. So the answer is D, Lewis base. Coming to the next question, arrange the following in the increasing order of their basic strength. So CH3NH2, CH3 twice NH, CH3 thrice N, and NH3. See, as I told you, primary amines, they are more basic than ammonia. This is because of the plus psi effect of the methyl group. More the number of alkyl groups or methyl groups, more is the basic character of that amine. But in case of methyl substituted amines, Apart from the plus I effect, other effect also comes into consideration, like steric effect and solvation effect. So because of this steric effect, because of this steric hindrance, the tertiary amines, they are less basic than the primary amines. So the correct order of the increasing order of the basic strength will be secondary amine, secondary amine is greater than basic strength of secondary amine will be more than the primary amine, and that will be more than the tertiary amine, and that will be more than ammonia. So the correct answer is A. Eighth question. Here there is an equation CH3 CH2Br aqueous potassium hydroxide gives A, that upon treating with potassium permanganate gives B, that upon treating with ammonia gives C, that upon treating with bromine in presence of alkali that gives the D. So D is CH3Br, CH3CONH2, CH3NH2, CHBr2. So which is the correct answer? So whenever ethyl bromide is treated with aqueous potassium hydroxide, you get ethyl alcohol. So A is ethyl alcohol. Now when ethyl alcohol is treated with potassium permanganate, so that is converted into acid, acetic acid. So B is acetic acid, and acetic acid when it is treated with ammonia, you get sodium acetate, and sodium acetate, sorry, not sodium acetate, ammonium acetate. And when ammonium acetate is heated, you get an amide, acetamide, that upon treating with bromine and alkali, so that you know that is nothing but Hoffman bromamide degradation reaction. So you get a primary amine, you get CH3NH2. So in this case, D is CH3NH2, methylamine or methanamine. So the correct answer is C. Next question. Which of the following forms propane nitrile as the major product? You have four options. First one is ethyl bromide plus alcoholic potassium cyanide. B, propyl bromide plus alcoholic potassium cyanide. C, propyl bromide plus alcoholic silver cyanide. D, ethyl bromide plus alcoholic AgCN. So which of the following forms propane nitrile? What is the formula of propane nitrile? CH3 CH2CN. So this is propane nitrile. Now alcoholic AgCN does not give you nitrile. it gives you isocyanide. So this and these options are ruled out. Now ethyl bromide, when you treat with alcoholic potassium cyanide, so you get, so this is propane nitrile. So the correct answer is ethyl bromide plus alcoholic KCN. Next question. The correct sequence of reactions to convert para-nitrophenol into quinol involves A. Reduction, diazotization, and hydrolysis. B. Hydrolysis, diazotization, and reduction. C. Hydrolysis, reduction, and diazotization. D. Diazotization, reduction, and hydrolysis. So, out of these four options, which is the correct answer? Para-nitrophenol. So, this is para-nitrophenol. Now, para-nitrophenol, you have to convert it into quinol. So, quinol is having this structure. Now, you have to convert this NO2 group into OH group. So, for that, you have to reduce this NO2 group. You have studied how to reduce nitro compounds into amines. So, first is reduction. When you reduce this, you get NH2. You get NH2. So, you get an amine. So, next step is you can do diazotization. So, when you do diazotization, you get this compound. Now, if you do hydrolysis with water, then you will get phenol. So, the correct steps of this reaction to convert para-nitrophenol into quinol is, first thing is reduction, then diazotization, and then hydrolysis. So, answer A is the correct answer. Question number 11. The conversion of metanitrophenol to resorcinol involves. This is also same as that of question number 10. Instead of quinol, they have asked resorcinol. So here also, the first step involves reduction, second step involves diazotization, and third step involves hydrolysis. So answer D is the correct answer. Question number 12. Benzyl amine is a stronger base than aniline. Benzyl amine is a stronger base than aniline because four options. The lone pair of electrons on the nitrogen atom in benzylamine is delocalized. B. The lone pair of electrons on the nitrogen atom in aniline is delocalized. C. The lone pair of electrons on the nitrogen atom is in aniline is involved in resonance. D. Benzylamine has a higher molecular mass than aniline. Now, if you see aniline, the nitrogen atom on aniline contains lone pair of electrons. Now, in aniline, these lone pair of electrons are delocalized. So, they are in resonance with the benzene ring. Whereas in case of benzyl amine, there is no such resonance. So, benzyl amine is a stronger base than aniline because this is ruled out. Nitrogen atom in benzyl amine is delocalized. This is not delocalized. So, it is localized. So, this answer is wrong. The lone pair of electrons on the nitrogen atom in aniline is delocalized. So, this is the correct answer. So, because of that, benzylamine is stronger base than aniline. These lone pair of electrons, they are not available for protonation. That's why it is a weaker base than benzylamine. Next question. An aromatic compound A having the molecular formula C7H9N on reacting with NaNO2 HCl at 0 degree centigrade forms benzyl alcohol and nitrogen gas. The number of isomers possible for the compound A is. So you get benzyl alcohol when this compound is treated with NaNO2 and HCl. So this compound might be compound A is CH3 NH CH2 NH2. So benzyl amine. So only when benzyl amine is treated with NaNO2 in the presence of HCl at 0 to 0 degrees centigrade, it gives benzyl alcohol with the liberation of nitrogen gas. So this is benzyl alcohol, benzyl amine. Now this benzyl amine can have isomers. So how many isomers are possible? So this is one isomer. The other isomer is, so this possibility is there. The other isomer, you can write it as this isomer. The other isomer possible is metaposition. So how many structures? 1, 2, 3, 4. And one more is possible that you can write it as NHCH3, N-methyl benzenamine. So 50. So totally, there are 5 isomers possible for this compound A, which is benzyl amine. So the answer is A. Next question. The correct sequence of reactions to be performed to convert benzene into metabromoaniline. So benzene, you have to convert benzene into metabromoaniline. So what all you can do? So for that, you can first carry out nitration. You get nitrobenzene. Then you can do bromination. So in that case, since nitro group is meta-directing, you get this compound. Then if you do reduction, you get nitro group is reduced to NH2 group. So the steps are, first step is nitration, second step is bromination, and third step is reduction. So nitration, bromination, and reduction. So answer C is the correct answer. Next question. One of the following amides will not undergo Hofmann bromamide reaction. As you all know, Hofmann bromamide reaction, when an amide, primary amide, is treated with bromine and alcoholic potassium hydroxide, you get a primary amide. So the starting product, the starting reactant is a primary amide. So in this is an amide, but it is a secondary amide. So here, this is an aromatic amine. So here you will get a primary amide, CH3CONH2. So this is the correct answer. Next question. In the sequence of the following reactions, P, bromination, and then reduction in HCl, you get Q. That Q upon treating with sodium nitrate and HCl at 273 to 278 Kelvin, you get, and then followed by treating with hypophosphorus acid, you get R, and then treating with KMnO4, you get this compound, orthobromobenzoic acid. So the starting compound P is, so if you take para-nitrotoluene, and then if you brominate, if you do bromination, you will get this compound. Then second reduction, here you will get NH2 group. Then if you treat that with NaNO2 and HCl, you get a diazonium salt. I have started with paranitrotoluene. And this upon treating with hypophosphorus acid, you get replacement of N2 group by H. So in that case, you get BrCH3, orthobromotoluene. And then if you treat that with KMnO4, you get this compound. So the starting compound P is paranitrotoluene. So if you try with orthonitrotoluene, orthobromotoluene, metanitrotoluene, you won't get orthobromobenzoic acid. So this is the correct answer. Paranitrotoluene is the correct answer. Next question. In the given set of reactions, 2-bromopropane reacts with silver cyanide to give you the compound X, and that upon treating with lithium aluminum hydride gives Y. So the IPC name of the product Y is, so there are four options: N-methyl propanamine, B N-isopropyl methanamine, C butane 2-amine, D N-methyl propane 2-amine. So 2-bromopropane. So this is 2-bromopropane. That when you treat with silver cyanide, so you get this compound. This upon treatment with lithium aluminum hydride, you get CH, sorry, this is silver cyanide. So you get an isocyanide. You get isocyanide. NC. So it is NHCH3. So 2-bromopropane. So when you react with silver cyanide, you get an isocyanide. So this is the isocyanide, NC. And this upon treating with lithium aluminum hydride, so you get this compound. So this compound you get. Now what is the name of this compound? So it is N-methyl propane 2-amine. N-methyl propane 2-amine. So that means the answer is D. D is the correct answer. Next question. In the following sequence of reactions, A giving A reduction B BHNO2 giving you CH3, CH2OH, alcohol. So the compound A is, options are A, propane nitrile, B, ethane nitrile, C, nitromethane, and C, D is an isocyanate. So there are two carbon atoms. So if you try with ethane nitrile, this upon reduction will give you NH2. This upon treating with HNO2, you get propyl alcohol. If you treat nitromethane, that upon reduction, you get CH3NH2. That upon treating with methylamine, you get methyl alcohol. So the option is not there in this. You take methane nitrile. So this upon reduction, you get ethanamine. Ethanamine, upon treating with HNO2, you get ethyl alcohol. So the correct answer is CH3CN, methane nitrile. So the option is not there. So the correct answer is CH3CN. Next question. An organic compound A on reduction gives compound B, which on reaction with trichloromethane and caustic potash forms C. The compound C on catalytic reduction gives N-methylbenzenamine. The compound A is, there are four options: nitrobenzene, methanamine, B, nitromethane, and D, benzenamine. So these two options are rolled out because it does not give you an aromatic compound. So out of these two, you cannot reduce this compound. So the correct answer is nitrobenzene. So when nitrobenzene is reduced, it gives you aniline. That upon treating with trichloromethane and caustic potash, you get an isocyanide. And this isocyanide on catalytic reduction That will give you N-methyl benzenamine. So nitrobenzene is the correct answer. So for today, this much is enough. So I have dealt all the topics on amines and also some of the important questions, previous year's questions of KCET. Thank you.